So 2023 paper 1 question 3a is the next on the list. Prove that the root of 2 is not a rational number. Now, another way of saying not rational is irrational. So we could rephrase this question and say, prove that the root of 2 is irrational. Now, what does that actually mean? Well, even now, if you pop root 2 into your calculator, I'll do it with you. If I do root 2, I literally get back root 2. So the calculator normally gives us the fractional answer first, and it was unable to. Why? Because that's what irrational means. It cannot be written as a fraction. If you change it to a decimal, you'll get 1.414213562, blah, 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 and it would continue. It's a non-terminating, non-recurring decimal, which is also evidence that it is irrational. Now, the question is not, is it irrational? So we know that it is. The question is, prove. Okay, prove that it's irrational. Now, not going to bother rewriting all of this because I remember we did this proof. So I'm going to go right back at the beginning of fifth year, actually. Where are we? Higher level, real. Irrational. There it is, third one down. Okay, so I'm just going to go through the proof with you now. So instead of writing it all out, I'll just kind of go through it. So it's a proof of contradiction. So in other words, you actually start by saying that it is rational, and then you contradict yourself. That's kind of how you do it. So if you were in the exam, the very first line you would do would be this one. You would write, assume the root of 2 is rational. So it's contradictory to what you're actually trying to prove. Now, if it is rational, then that means the root of 2 is equal to a over b. So where a and b are elements of z, b cannot be 0, and the highest common factor of a and b is 1. Now, let me just explain that again. I would have explained it at the time, but let's just revisit that. So what we're saying is, if it is rational, it can be written as a fraction. So we write something that looks like a fraction, something over something else, because that's what fractions look like. Now, what we're saying is that a and b are elements of z. In other words, they are whole numbers. Okay, so they are whole numbers, positive or negative. We're saying that b can't be 0. Now, the reason for that is because we can't divide by 0. That would, that math error on our calculator. So that's just a kind of like the small print. And then the highest common factor of a and b is 1. In other words, what we're saying is this fraction is going to be in its lowest terms. So it's not going to be, for example, 3 over 6, because you could break that down further. But it could be, for example, a third. So that's kind of the idea of that. So you have to have those 3 sentences. Now, what do I do? Well, to get rid of a square root, I square both sides. So when I square the root of 2, I get 2. And when I square a, I get a squared. And when I square b, I get b squared. So now I have, and I pop, the reason I'm popping 2 over 1 is now that I cross multiply, I get 2b squared is equal to a squared. Now, that sentence that's highlighted in yellow tells us that 2 is a factor of a squared. Okay, now how do I know that? Well, because the yellow sentence tells me 2 multiplied by b squared is equal to a squared. So by default, b squared would be a squared divided by 2. In other words, 2 should divide into a squared. So that's what that says. And then we learned another maths fact at the time was that if something is a factor of a number squared, then it's also a factor of the number, not squared. So if 2 is a factor of a squared, therefore 2 is a factor of a. Now, I've now proved that 2 is a factor of a, but now I kind of need to go back and say, okay, we're going to let a equals 2k this time. K is an element of z. Now, why 2k? Like, where the hell did I get this from? Well, I've written over here, I mean, if you were proving root 3, you would use 3k. If you were proving root 5, you would use 5k. So you're going to use this format regardless. In this case, we're doing root 2. So because I'm doing root 2, I'm using 2k. So that's where I've gotten this from. Now, the reason I'm doing it, you'll see in a sec, but You have to remember that. That's one of those lines you're going to have to remember. And I've also said that K is an element of Z. In other words, again, it's whole, either positive or negative. Once I let A, so it's like I'm going back to the opening line, but instead of A, well, actually not the opening line, the highlighted line, I should say. So instead of A, I have a 2K squared. So that becomes 4K squared, and then I get B squared on its own, which gives me 2K squared when I divide the 2 in. So 2 is a factor of B squared, okay, which means 2 is a factor of B. Now, 2, so this is a key line, 2 is a factor of A and B. The highest common factor of A and B was supposed to be 1. That's what we said at the start. This is a contradiction because we've now discovered 2 is a factor of A and B, so it is more than 1. So we have contradicted ourselves, so therefore the root of 2 is not rational, therefore it is irrational. Now in this exam question, you can actually stop there because that's what you were asked, prove that it's not rational. And that's it. So if you saw that in the 2023 exam, you would have been delighted because you would have had to really do no maths. It was just a case of learning, oh, I've done this proof and I'm just reproducing it. So that's it.